Okay guys, today we're in Chapter 8, Section 6, and we are going to solve rational equations. So when you see the word rational, what word should come to your mind? Ratio. And a ratio is something divided by something else. And then how do we solve those? Well, there can be really easy ones, like if I had 3 over x is equal to 4 over 5. When I have 3 over x, what word should I think of? Ratio. And then that tells me it's what kind of equation? Rational. All right. So why is this not as easy as normal? Like, what do you observe about this that's a little bit more complicated?
The x is on the bottom.
The x is on the bottom. And what do we call the bottom? Denominator. All right. So if we're trying to solve for x, tell me, you guys just kind of talk out loud, something that we could do. Logan, what would you do? Okay, tell me what you don't like. Tell me what you wish was not the case.
I wish that the x was not on the bottom.
You wish the x was not in the what?
Denominator.
Denominator, thank you.
Could multiply both sides by x.
If I multiplied both sides by x, is that allowed?
Yes.
Is it a pretty smart thing to do? Yeah. So I'm going to multiply both sides by x. So I have 3 over x is equal to 4 over 5. And then I'm going to multiply by x and multiply by x. X over x makes? So I have 3 is equal to what? 4x over 5. Am I closer to a solution now?
Yes.
Yeah. Josie, what are you going to throw out? What would you do next?
Multiply both sides by 5.
I'd multiply both sides by 5. That way we got rid of all of our denominators, right? So I'd say 5 times 3 is equal to 4x over 5 times what? 5. 5 over 5 makes? So I have 4x is equal to 15. And now x is equal to what? 15 over 4. Not 4/15, 15 over 4. Would you agree? Okay. So is that the right answer? Yes. Did we get to it in a good way?
Yes.
Yeah. How can we get to the answer quicker? Okay. If I have 3 over x and 4 over 5, what did we do one at a time? We got rid of our whats? Denominators. So to solve these problems, really in general, what are we trying to do? Get rid of the denominators. Is there a way that I could get rid of all the denominators at once, Mario?
Could you multiply by the least common denominator?
Yeah, multiply by the least common multiple. Okay, now in this case, x and 5, the least common multiple is going to be 5x, right? But like if it was 10, if it was like 5x and 10, then the least common multiple would be 10x. But you multiply by the least common multiple. In this case, the least common multiple is what?
5x.
Yeah, 5x. The least common multiple of the denominator. So I'm going to multiply by 5x. I'm going to multiply by 5x. X over x makes 1. What am I left with over here? 15. 5 over 5 makes 1. I'm left with what? 4x. X is equal to 15 over 4. Boom. Does that make sense? Okay, that's the way you do it. That one was easy. They're not always going to be that easy, but you're always going to work them exactly the same way. So let's say I have 9 over 28 plus 3 over x plus 2 is equal to 3 over 4. Okay? Why does this problem make me very unhappy? Yeah, there's a lot of denominators and the variables in the denominator. How do I want to solve this? What is the strategy? I want to what? Yeah, multiply by the least common multiple. That's right, but tell me what I'm trying to do.
Eliminate the denominator.
I'm trying to eliminate the denominators. Okay, Kelsey, can you help me with what the least common multiple of this would be? One thing is I'm going to need what? A what? A what?
Wait, what? An x plus 2.
An x plus 2. And then I'm also going to have to hold a what?
A 28.
A 28. Okay. And then what about that 4? Do I have to do something with that 4?
No, because it goes to 28.
Yeah, the 4 will stay in the 28, right? So I'm taken care of. So now I'm going to have something over 28x plus 2, and then I'm going to have something over 28 onto x plus 2, and then that's going to be equal to something over 28x plus 2. Now I have to change the numerator by the same amount that I changed the denominator by. So first of all, I started with what in this first term, Josie? I started with a what? A 9. Okay. But now, what did I multiply the denominator by?
X plus 2.
So
you're going to have
what do I have to put in the numerator?
9x plus 18.
What? Oh, no, you do it. Put the step in. I'm multiplying by x plus 2, right? Levi, do you see?
Yes.
Okay, don't skip that step. Okay, Kelsey, help me with this. I have 28x plus 2. What did I multiply the denominator by?
28.
So what do I need to multiply the numerator by?
28.
And what was already there?
A 3.
So it's 3 times 28. Okay, Jaden, help me with this one. What did I have there to begin with?
A 4. A 3.
A 3. Okay. And then what did I multiply the denominator by?
7.
Okay, 7 is one thing. And what else?
X plus 2.
X plus 2. Is everybody happy?
Parentheses over.
Yeah, you better not be happy, because if I don't put parentheses around the x plus 2, that's going to be 21x plus 2. What do I have to put? Parentheses. Okay. Now let's do some math. Okay, let's do some math. So I've got the least common multiple. Now what can I do? I can multiply both sides by what? 28 onto x plus 2, right? I can multiply both sides by 28 onto x plus 2. Now I've gotten rid of all of my what? Denominators. So I'm going to have 9 onto x plus 2, okay, plus what's 3 times 28?
84.
84, okay. And that's going to be equal to 21x plus what? 21 times 2 is 42. Is that fair? Okay, now, Levi, let's distribute this 9. So I have 9x plus 18 plus 84 is equal to 21x plus 42. All right? How would you guys suggest I move forward with this? Like,
Subtract 42 from both sides.
I'd subtract 42 from both sides, and then I would subtract
First
the
you
9.
combine like terms.
Yeah,
and all
combine
that.
that term.
Okay, so let's go. 9x plus, what's 18 and 84?
104.
No.
102. Sorry.
102 is equal to 21x plus 42. Okay, I'm going to subtract the 42, and then I'm going to subtract the 9. Why? There's a lot of different ways you could do it. Why do I want to do it that way?
So you don't get any negatives.
Yeah, I kind of like to avoid negatives if I can. So 21 minus 9 is what? 12x. What's 102 minus 42?
60.
60. So x is equal to 60 over 12. And 60 over 12 becomes what? X is equal to 5. Okay. Now we better check ourselves, right? So let's put it back in. 9 over 28 plus 3 over what? 7 is equal to 3 over 4. Okay. So this would be 12 over 28 plus 9 over 28 is 21 over 28 multiplied by 7. 21 over 28, it works, right? So we got the right answer. Does everybody see that? Okay. These are pretty straightforward, right?
Yes.
Okay, but it's just you've got to do the math you know. And this one's going to be a little harder. So I'm going to have r plus r squared minus 5 over r squared minus 1 is equal to r squared plus r plus 2 over r plus 1.
We can factor one.
Yeah, so does this problem make me happy or sad? Pretty sad. How come? Bunch of denominators. So I want to do what? I want to get rid of my denominators. But before I do, when I see all this, before I do anything else, I better try to what? All my numerators and denominators that I can. I should always try to do what, Mario?
Factor.
Factor. And Levi, you saw it right off the bat. Okay, you immediately saw what we should do. I just wanted to make sure everyone saw where we were going. Okay? So can I factor r squared minus 5? No, it's not a 5's not a perfect square. I can't factor that. So I'm going to have r squared minus 5. Okay, Jaden, can I do anything with the denominator?
Yes.
What is it?
It's a difference of perfect square.
Very good, Jaden. Very good. And so, Jaden, what would that be?
R minus 1 and R minus 2.
What?
Or plus 2.
What?
R
one.
plus 1.
R minus 1, R plus 1. Okay. Is equal to, can I factor that? R squared plus R plus 2? I don't think I can factor that, right? Over R plus 1.
Isn't that just 2 times, like, no, never mind.
Yeah, it doesn't work. Okay, so I need to find my what now? My least common multiple of my denominators. What is the least common multiple of the denominators going to be, Josie? Tell me everything I'm going to need.
R minus 1
R minus 1, and what else?
times R plus 1.
R plus 1. Okay. Now, let's multiply both sides by what?
Minus 1 r plus 1.
Yeah, which is the what?
We call it
Least common multiple. So I'm going to multiply r minus 1, r plus 1, and then r minus 1 and r plus 1. All right. Now, do you see how important it is to use your parentheses? Because you're multiplying the whole side by that. Okay? So the first term is going to be r onto r minus 1 and r plus 1, right? And then plus r minus 1 over r minus 1 makes what? R plus 1 over r plus 1 makes 1. So what am I left with?
R squared.
Okay. Now, r plus 1 times r plus 1, that makes what?
1.
So I'm going to have r squared plus r plus 2 times what?
r
Minus 1.
What?
R minus
r
1.
minus
R minus 1. Is everyone happy?
Yeah.
Why are you not happy, Jaden?
Because you don't have parentheses.
Right. I didn't put my parentheses. Okay. Now, tell me one reason that we are happy. Yes.
I just have a question
Uh-huh.
real quick. On this one, okay, so on the last one,
Mm-hmm.
we got like the bottoms all the same before we did that, or we
Yeah.
do this one after?
This one, it's just, I did it that way last time so you could see what we're doing. This time I'm just saying the easy way is just find the least common multiple, multiply both sides by the least common multiple. Okay, thank you for asking. Does that make sense?
Yes, sir.
Okay, so why am I happy? I've gotten rid of all my whats.
Denominators.
Why am I not so happy?
Because you have to multiply out.
I got to multiply this stuff out, right? I got to multiply this stuff out. So we're going to do a lot of FOILing. So this is going to be r onto, what's r minus 1 times r plus 1?
R squared.
Minus 1, right? And then I have, this is pretty easy, r squared minus 5. And I'm going to go ahead and distribute. I'll come back and catch up on this one. So I'm going to have what? R cubed minus r plus r squared minus 5. Okay, Jaden, can you FOIL this for me? I would start with r and go all the way across, and then minus 1 all the way across. So what am I going to have?
R cubed
Uh-huh.
plus minus
No, we're going to go with the r all the way across. So r cubed plus what?
plus r squared.
R squared plus... Okay, Jaden, do you see what I'm doing? This r has to multiply every term, right?
Okay.
So it's what?
R squared times r.
Which is what?
R cubed.
And then
R times r is r squared.
plus
2 times r.
2 times r. Am I done?
No.
I got to do the what?
Negative 1.
So it's what?
Negative r squared
Minus r squared
minus r
minus r
minus 2.
minus 2. Oh my goodness, what's one thing that's going to make me really, really happy here?
You can factor it.
No, I can't factor, but what's going to make me happy?
R cubed and
The r cubed, I can subtract r cubed from both sides, right? So at least I don't have to deal with that. Now let me combine like terms. So I'm going to have r squared minus r minus 5, right? R squared minus r minus 5 is equal to, oh look, r squared minus r squared, that makes 0. And 2r minus r makes r. Okay, now I've just got to put them together. So minus r, this would be r squared minus what?
R squared equals 3.
R, what?
Oh.
I've got to
Minus
do
5.
what?
Minus 2r.
Yeah, minus 2r. I'm subtracting r from both sides, so this r comes over minus 2r. And then what do I have to do with the 2? I have to do what with the 2?
Add it to both sides.
Add it to both sides, and so then I have, if I add 2, I have minus 3 is equal to 0. Now what is this? What can I do with this? R squared minus 2r minus 3. What can I do with that?
Factor it.
Factor it. Okay? So I'm going to have an r and an r. It's going to be equal to 0. Are the signs the same or different? Different. So plus and minus. So it's going to be plus what and minus what?
Plus 1 minus 3.
Minus 3 and plus 1. Okay, so now I've almost got it solved. What do I have to do to solve it now, Jaden?
You have to set them both equal to 0.
Yes, thank you, Jaden. R plus 1 equals 0. R is equal to?
3.
What?
Negative 1.
Nope. We're doing this one. This is r minus 3 equals 0. If r plus 1 is 0, what's r? Negative 1. R is equal to negative 1, and r is equal to what? 3. Okay. Do I stop here?
Yes. No.
What?
No, you have to-
Check it.
yeah.
Check it for what? Extraneous solutions. Okay? So let's try it with a 3. Okay? Let's try it with the 3. This would be 3 plus 3 squared is 9 minus 5 is 4. 3 times 3 is 9 minus 1 is 8. Is equal to r squared is what? 9 plus 3 is 12 plus 2 is 14 over 3 plus 1 is 4. So that's 7 halves, and 3 plus 1 half is what? So this is a what? Solution. I got to check the other one. Minus 1 plus, what's minus 1 squared? 1 minus 5 is? Minus 4. And then 1 minus 1 squared is what? 1 minus 1 is 0. What is this? No, this is an extraneous solution because you can't divide by 0. Does that make sense? Okay, so you had one solution. Does that make sense?
Yes, sir.
Okay, homework 10 through 15. You guys leave some time.